insulin resistance manifests different diseases. So, for instance, type 2 diabetes is a manifestation of insulin resistance at the level of the liver. Polycystic ovarian syndrome is a manifestation of insulin resistance at the ovary. Cardiovascular disease is a manifestation of insulin resistance at the heart. Alzheimer's disease, we are learning, is a manifestation of insulin resistance in the brain. So this phenomenon of insulin resistance is extraordinarily important for all of these chronic diseases, but it's regio-specific. Different tissues manifest insulin resistance at different times. And it is because of that that we end up with these different manifestations. 1/4 of all the people on the planet, 2 billion adults, have fatty liver disease. Now, prior to 1980, if you had fatty liver disease, you were an alcoholic. But these are not alcoholics. We don't have 2 billion alcoholics. So why do they have liver fat? And why is the liver fat generating the insulin resistance? And the reason is because the liver is the primary target of insulin action. And so when your liver cells start accumulating fat, they don't work very well. And so your pancreas has to make extra insulin to make the liver do its job. The liver is really ground zero for why we have this phenomenon of insulin resistance.
Maybe like, what is insulin resistance? How do we define it?
Well, I'll be honest with you. Before we define insulin resistance, I think we ought to define insulin. Insulin is a hormone. It's a chemical that is made in the pancreas, circulates in the blood, and goes to different parts of the body to do different things. And it does different things in different tissues. The main thing that insulin does is it stores energy. Insulin is the energy storage hormone. The first issue is, why is insulin resistance the big issue? Their very first attempt was to measure insulin. And what they found was that when they took the blood of type 2 diabetics, they expected to see no insulin. After all, they have diabetes. But what they saw was that the insulin levels were actually higher. So how come insulin levels are high when insulin function is low? And the answer is because the receptors for insulin, the proteins that bind insulin on the cells, have been downregulated. They are not working as well because there are fewer of them and because the signaling that goes on beyond that receptor is dysfunctional. And that is really what insulin resistance is about. Why does that happen? And it happens in different tissues and it happens for different reasons. And in fact, those different tissues are important in terms of why insulin resistance manifests different diseases. So, for instance, type 2 diabetes is a manifestation of insulin resistance at the level of the liver. Polycystic ovarian syndrome is a manifestation of insulin resistance at the ovary. Cardiovascular disease is a manifestation of insulin resistance at the heart. Alzheimer's disease, we are learning, is a manifestation of insulin resistance in the brain. So this phenomenon of insulin resistance is extraordinarily important for all of these chronic diseases, but it's regio-specific. Different tissues manifest insulin resistance at different times. And it is because of that that we end up with these different manifestations.
Why are we not measuring insulin?
So here's the problem. We have this thing. It's called the American Diabetes Association. And I'm not a fan, to say the least. I'm not a fan. And the reason I'm not a fan are twofold. The first is that they state categorically that diabetes is a chronic, degenerative, unremitting, chronic metabolic disease with no treatment and no cure. That's what they say. Go to their website. That is what they say. None of those things are true. And Virta Health has proven it, among others. I mean, you've proven it too. And I've proven it. The fact of the matter is that type 2 diabetes is eminently reversible. You have to fix the diet. But they don't say anything about the diet. What they said was, give all the carbs you want, just give enough insulin to cover it, which is also not true. I mean, yes, you can cover the glucose rise with insulin, but all you're doing is actually fomenting further chronic metabolic disease. So you're fixing the glucose, but the glucose isn't the problem. The insulin's the problem. And the more insulin, the quicker you die. And that's been shown every 50 ways from Sunday also by a zillion different studies. United Kingdom Prospective Diabetes Study, the Accord Study, the Miraglitazar Study, the Advanced Study, etc. So the bottom line is, we don't need more insulin. We need insulin to work better. And the American Diabetes Association is basically saying, give more insulin, which is why I'm not a fan. The American Diabetes Association very specifically, again, on their website says, do not measure fasting insulins. Now, why do they say this? I think it's the most important thing to measure. It's the first thing I measure. But they say don't measure it. Why is that? They say it for two reasons. The first reason is, as you just said, insulin assays across the country are not standardized. That is true. Now, one of the reasons it's not standardized is because certain assays, radioimmunoassays, will pick up other structures that will be confused with insulin. The main one being proinsulin. Now, proinsulin, as you know, is the precursor to insulin. Proinsulin is a single polypeptide that then has to be cleaved by prohormone convertase 1 in two sites in order to liberate a piece of the peptide called C-peptide. And then you have the mature insulin. When your pancreas is under duress, when it's trying to lower the blood glucose, and it can't because insulin resistance is so severe, it's got to get every molecule of that it's making out into the periphery as fast as it can. That prohormone convertase 1 doesn't have enough time to cleave off the C-peptide and generate the mature insulin. And so it will release this immature, non-cleaved form called proinsulin. And proinsulin has about 5% of the activity of the mature insulin molecule. The problem is that proinsulin will get picked up in the insulin assay. So when you measure insulin, especially within a radioimmunoassay, you're not just measuring insulin, you're measuring proinsulin too. And sometimes you'll even measure IGF-1. So depending on the assay, your assay may not be specific for insulin. That is true. Who cares?
Who cares? Yeah. I mean, it's the relative changes over time, longitudinally. Yeah.
Right, exactly. The point is, in any given patient, if the insulin's going up, it's a problem. And if it's going down, it's good. That's all you need to know. Within any given patient, not how the patient fares against any other patient, but within the same patient, who cares? As long as the insulin assay is being done in the same place each time, who cares? So that's problem number one with the ADA's stance. Problem number two with the ADA's stance. They say fasting insulin does not correlate with obesity. That's correct. I agree, does not. It correlates with metabolic health. And for all the reasons that we just talked about just a few minutes ago, okay, because Subcutaneous fat is protective. Well, subcutaneous fat is the majority of the BMI. So, in fact, you can be metabolically healthy obese and have a low insulin, but still be obese, because fasting insulin does not correlate with obesity. That's right. It doesn't. That's not why you draw it. You draw it to determine metabolic health. And the thing is that fasting insulin will change way before fasting glucose, way before glucose tolerance, way before hemoglobin A1C. So it is a much earlier arbiter of metabolic dysfunction. And by the way, this is why fasting insulin is part of Levels Health's Labs 2.0. And the reason it's there is because I made sure it was. My decision.
It's like unfathomable to even think. I mean, we are accepting that insulin resistance is a problem, and insulin is the most important metabolic hormone, and that even other investigators and people who teach this subject at medical schools are, know enough about the data to know that insulin starts to go up before type 2 diabetes becomes diagnosed. So it just seems like unfathomable that this is not part of a standard, that someone needs to step up and put this. I mean, there's some historical baggage there with the assays and everything, but geez. So, it's kind of like, what do we do moving forward? Something's got to change to acknowledge this. And then I guess most importantly, I mean, we should probably discuss, what are evidence-based, because in school we have to teach about evidence-based therapeutic interventions to treat and also to reverse. Like, what should be taught, from an evidence-based perspective?
In my view, having done this for 40 some odd years, what I say is that we need to get the insulin down any way we can.
What range? So let's talk about like what the ideal ranges should be and what to do once it starts creeping up.
Right. So ideally, the fasting insulin should be less than 10 microunits per milliliter. Ideally. The lower, the better. Okay, marathon runners who eat well will have fasting insulins of 2 or 3. I would say anything less than 10 is fine. Once you get above 15, you've got insulin resistance. And that's sort of like the break point. And if you have insulin resistance, you're not going to be able to lose weight until that insulin comes down, because that fasting insulin is always there, and it's always pushing on your fat cell. It's always telling your fat cell, store more, store more. And you can't reverse that. You can't get lipolysis. You can't get the fat out of that fat cell until that insulin goes down. You got to get insulin down any way you can. Now, in my life, there are 4 ways to do that. Diet, exercise, drugs, surgery. Those are the 4 ways. Okay? Diet is where you start. Fix the diet. Fix the diet. How do you get insulin down? Very simple. Don't let it go up. Well, what makes it go up? Really only 2 things. Refined carbohydrate and sugar. Those are the 2 things that make insulin go up. Fat does not make insulin go up. Amino acids do make insulin go up, but you need amino acids. I mean, 15% protein. You can go up to 20, but the amino acid that really makes insulin go up is leucine, branched chain amino acids. And so, branched chain amino acids are what's in corn, corn-fed beef, chicken, and fish. So that's one of the reasons why we also say, skip the ultra-processed foods, because that's basically, what corn-fed beef, chicken, and fish is.
So